Okay, let's solve some really hard problems, okay? Sadly, this problem was on I think it was on the sample test, or maybe it was on the last year's test or something like that. So evidently IB thinks we ought to be able to solve for the acceleration of this system here. I'm going to show you how to do this with dynamics, which is like using F equals ma. And then I'm going to show you how a trick for solving dynamics, because I think it's hard to solve these problems using dynamics. Yet we can do it. So let's do this. Okay. So notice that this string is wrapped around this cylinder, right? And this mass is going to fall possibly some distance, but not necessarily, right? And it's going to be exerting that force, whatever the tension is in that string. And by the way, the tension in the string is not equal to the weight of this mass, because this thing is, of course, accelerating downward, right? Okay, so it's actually less than the weight of that. So we're going to have to set up a system of equations for this, right? But whatever that tension is, there's definitely a tension in there. The tension stays constant. Whatever that tension is times this radius is the torque, right? So definitely we've got R times T. That's our torque, right? Okay, and then that's going to equal I alpha, right? Okay. And that's going to be I alpha of this, right? So now we can substitute, right? So that's going to equal, it's a cylinder, let's assume, right? So let's say it's 1/2 m1 r squared, right? And then the velocity, or for the alpha, we're going to substitute the linear acceleration of this mass over the radius, right? Okay, so I'm using the substitution that I is 1/2 mr squared. I'm assuming that the pulley is a cylinder, right? And then I'm saying that if A is alpha r, then alpha is A over r. Okay, so the angular acceleration of this thing is just simply the linear acceleration of the string, right, divided by the radius. Okay, so now if you're paying attention, the R goes the way of the bison. I can go boop, and then I can go boop, like that. Okay, so I get that the tension in that string is 1/2 m1a, which is kind of a neat little thing there, right? Okay, I can simplify that first expression, right? Now let's look at the mass on the string here. We'll set up another equation, because sadly we don't know T and we don't know A, right? But if we set up another expression here, right, we've got a force down of m2g and a force up of T, right, the tension in there, right? So if I go m2g minus T, that has to equal m2a. This is at least somewhat familiar from our pulley problems, right? Okay, so remember, I'm making the acceleration positive. I'm making it positive here, right? So m2 is the protagonist minus the antagonist, right? Is that. Okay, now obviously all I have to do is substitute this for that, and I'll have an expression for A. So let's do that. Okay, I'll do it over here. M2 G minus, now instead of T, I'm going to go 1/2 M1A equals M2A. And now we're almost there, right? M2G equals M2A plus 1/2 M1A. And you see this a lot, right? The pulley, since the moment of inertia is 1/2 mr squared, right, contributes kind of like a half, right? Because a lot of that mass doesn't do much moving, right? And some of it does a lot of moving, right? Okay. And then now we can solve this, right? We can go M2G equals A outside of M2 plus 1/2 M1, and then A is going to equal M2G, which is the sole protagonist, right, divided by all the inertia. So all of M2 and half of M1, which intuitively kind of makes sense, okay, that we would have the force, sort of the net force causing it, right, divided by the inertia, right? Why is it half of the pulley? Well, because remember, when the pulley moves, some of the mass is near the middle, right? And so it doesn't do a lot of accelerating. Its linear acceleration is rather limited. Okay, now obviously we can plug in numbers, so let's do that, right? A is is M2 is 0.543 times 9.81, right, and then divided by 0.543 plus half of that other one. The other one's 15.7, so half of 15.7. All right, let's calculate that. Okay, so 0.543 times 9.81 divided by parentheses 0.543 plus 0.5 times 15.7, right parentheses, and I get that the acceleration is 0.63467, right? And then to find the velocity of impact, right? If the height is 0.195 meters, right? We can do that here. Here, use a different color. How about red? Okay, I'll use v squared is u squared plus 2as. Okay, so v is the square root of 0 squared plus 2 times 0.63467, and then our height is 0.195 meters, evidently, right? Okay, so I'm going to go that times 2 times 0.195, then I'm going to square root it, and I get 0.4975 meters per second. Okay, now in the next video, I'm going to show you how to do this. In fact, I'm even going to show you how to get this expression without using systems of equations, but just simply using energy, okay? Energy is definitely the way to solve these things. So let me show you that.